Hi, welcome to Raw Math. Today I'm doing a series of videos on functions, their graphs, and specifically parent graphs. In this video, I have 3 parent graphs to show you: absolute value, the squaring, which is also called the parabola, and the cubing function. So the way I'm going to do these is I'm going to do a table of value to help us see what's going to happen. If you have a graphing program like Desmos.com on your computer, or maybe a graphing calculator, you can do that as well. But we're just going to look at this with a table of values. So I'm going to look at x, and our function is k of x equaling the absolute value of x. I'm going to look at -2, -1, 0, 1, 2. So the absolute value of -2 is a +2. Absolute value and squaring are the 2 ways in which we can clear a negative and make it positive. The absolute value of -1 is a +1. The absolute value of 0 is 0. The absolute value of 1 is still a +1. Absolute value doesn't mean opposite, it means positive. So whenever a number comes out of absolute value, I always think of it as a jail cell. When a number comes out of jail, it's going to be positive, and the absolute value of 2 is 2. So we have -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Absolute value is the V graph. So on this side, it's going to come up with an arrow. On this side, it's going to come up with an arrow. Notice I'm using a ruler. It is always good to use a ruler when graphing straight lines. They look much nicer. And I use arrows at the end of my lines because these lines are infinite. And if I don't use a arrow, I have a line segment, which is not the same thing. Okay, for my next function, my squaring, I have x and f of x equals x squared. Again, this is the second way I can take a number and clear away a negative. So at -2, I have 4. At -1, I have 1, 0, 0, 1, 1, 2, 4. The middle looked the same, but the ends, we got a little bit bigger. So -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Exponents make a graph curvy, whereas no exponents, that's when you have a line. So the absolute value had lines because there was no exponents. Not all absolute values will be lines. If I can have a cubic in an absolute value, and then I would have something that was curvy and positive, but because it was an x inside that absolute value, it ended up looking like a v. So it was the linear within the absolute values that gave us the v. So here I have a curvaceous parabola. So next I have my cubic. Because of the nature of my cubic, g of x equals x cubed, my -2 is going to take me down to -8. A negative times a negative is a positive, but then times -2 is going to be a 4, but then 4 times -2 is a -8. -1, -1, 0, 0, 1, 1, 2, 8. Because I'm going all the way to 8, I'm actually going to rescale my outputs so I can get this all graphed, because my graph only goes 1, 2, 3, 4, 5. So I'm going to say that this is -2, this is -4, -6, -8, -10, 2, 4, 6, 8, 10. An unmarked scale is assumed to be 1. So my input is staying at a scale of 1, whereas my output is being doubled. So -2, -8, -1, 1, 0, 0, 1, 1, 2, 8. And so my cubic will also be curvy. It's just one will be positive, the other leg will be negative. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video.